Okay, now let's enter into how do we define and use a class. And using a class. Okay, so time is ticking. Let's just have a time check. All right. So let's see if we can give all the introduction necessary in the next 1 hour. Okay. So let's see how we can define a class. So first thing is that you have a header. So which will be going into, let's say, a.h. So a.h because you are trying to define a class, let's say, called A. Okay. So in the class, by default, whatever you have, so in the class you have, as I said, class is a type of repository of data, right? So class naturally is derived out of originally like C structures, right? So in the C world, there used to be struct, right? So in the struct, you can define int x, int y, and these are just collection of these data, right? But when you put inside the struct, by default, the struct members are public, which means that they're accessible from outside without any problem. So if you define a struct, let's say s, right, and you say s small s, right, so you can directly access s.x equal to 5, right? So this luxury you have of accessing an element because they are public by default. But in the class, that thing is actually private by default. So if you do not specify the section, so there are 3 kinds of section you can create inside. You can have a private section, you can have a public section, and you can have a protected sections. So private section, that is private to the outside world, public, that is public to the outside world, and protected, that is actually accessible by the derived classes only, but again, it is private to the outside world. So in class A, when you are defining, let's say, void foo1, when you do not define this function, this is simply a declaration. But when you have this void foo2, let's say another function, and you actually define it inside the class itself, right? Then this is a definition of the function. But very importantly, when you are doing this inside the class, then this function will be inlined. All right, so we are working on how to define and use a class. So we're defining a.h in the as a header. So you have class A, and I mentioned that by default everything is private. So in the private section, typically we put the members. So int some data. And one very important mistake, one important thing to remember is that class has to end with a semicolon, right? And typically we want to expose the methods that you want user to interact with. So here you can say void foo1. And as I was mentioning, if you define it here, then the effect of that would be that when you are actually calling a function which is fully defined inside the class, it will be fully inlined. So it would not have the effect of actually a function call. But probably that detail is not so much important from your perspective. So it's customary to divide our program into header file, where you are defining some, whatever the class name is, you can derive the file name from that. And so class name .h, and the corresponding source you can define as a.cpp. So here, obviously you have to include, so hash include in double quotes a.h. Sometimes people like to actually call it HPP to go with CPP, but both works. So we can say a.hpp in double quotes. So when you want to define this particular function, now you would have to first write void, so what its return value is, then followed by, you have to give, because this is a member function, so it needs to know before writing the member function, where does the member function belong to? So this is the scoping operator. So it says that I belong to class A. So therefore A colon colon, then foo1. And then now you can define this function here in the a.cpp. So this is header, this is source. So what should be the usage? The usage would be somewhere, maybe inside the main function or inside some other function, you can say a. So this is essentially called instantiation. So this is your object. This is class. So this is the type of the object, and this is the object. So when you invoke, this is called static instantiation. So static because it is going into the stack memory. So static instantiation, when you do, the objects are allocated in the stack. So static instantiation means allocated in the stack part of the memory. Okay. Now, very important thing, in C++, there are 4 vanilla functions which are always generated for you. Even if you don't write them, they're there. And those vanilla functions, so let's call it C++ vanilla functions. There are 4.
Sorry, I have a quick question.
Go ahead.
Sorry to interrupt. For the header file, my understanding was that usually it's like a, for example, a.h, not like a.hpp, or at least when we did it in Comp11.
Well, as I said, like sometimes people like to use HPP because it nicely goes with.
Oh, okay.
So both choices are valid. There is no problem. HPP will also.
Okay. Makes sense. Thank you.
All right. So what are the 4 vanilla functions? Even if you don't define it, the compiler defines for you. What are those? First is the constructor. Second is the destructor. Third, who can tell me what is the third one?
Copy.
Very good. Copy constructor. And what is the fourth one?
Assignment, I think.
Very good. Assignment operator. So we're going to get into that. So these 4 functions are auto-generated. So even if you don't do it, they're going to be generated. So when you are instantiating a static instantiation you're making here, at this point, this is going to call the constructor of A. Okay. We're going to get into how the constructor looks like. So now, constructor is typically used for initialization, whether it is initialization of variable or initialization of memory, allocation of memory, initialization of variables, everything is done in the constructor. Destructor is typically used for cleaning up of your memory. Copy constructor and assignment operator we'll see shortly why they exist. So now let's change color. So what do you do after the static initialization or static instantiation? Then now you can, with the dot operator, now you can invoke the member function. This is the member function or the class method. So you can invoke that. So you can say a.foo1. So this now you can actually call. Now you are able to actually call it because it is defined in the public section. If you did not, if you somehow skipped this public section, you would not be able to call it because by default, everything is private in C++ world. Okay. And we will discuss why it is private, maybe a few lectures down the line. All right. So who can tell me if I write this code, when is the destructor coming into picture? We said that the constructor is coming into the picture here. If I write this piece of code inside, let's say my main function, do you think destructor is invoked anywhere?
It's invoked automatically at return 0 at the end.
It's basically executed here. So this is when the destructor gets called. So this is our static allocation. So this is static allocation of memory for the object. Let's talk about how there could be another usage of this. The another way of allocating would be dynamic allocation. So dynamic allocation would be, again, writing some block. I mean, this block can be anything inside your function. So dynamic allocation would be looking like, obviously you have to have a pointer. So you will say a star a equal to, you have to use new operators when you are using new. So then new of what type? So then the type is a, and you put open and close parenthesis. So this calls this is called default. So what the constructor that is automatically there is what is called default constructor. We'll understand what is default soon. So now if I have written here like this, star a equal to new a, who can tell me how am I going to invoke now foo1 for this particular object that I dynamically allocated?
Can you do lowercase a and then the arrow
Exactly.
pointing to foo1?
Exactly. So I'm going to do this arrow because it's a pointer, right? So I'm going to now invoke the member function like this. Now who can tell me where is the destructor getting called here?
When
When you
the allocation is freed.
Do you think destructor is ever going to be called in this code? The code that I wrote here?
No, you have to call delete, I think.
Exactly. So that is the key difference between the static and the dynamic allocation. Here you have to have an explicit call to delete on A. Okay. Very important. So now, obviously, as I mentioned before, if you want to allocate an array of type objects, then you can do a star a equal to new a. So dynamic allocation, the beauty of that is that this can be variable length. So this can be dynamically determined what should be the size of this block of memory. So when you do that, then what happens is that this calls the default constructor n times. That's the effect of this when you put an parenthesis n there. And the corresponding delete for this would have to be delete with an open and close parenthesis and then a. Okay.